A loom is a device used to weave cloth and tapestry. The basic purpose of any loom is to hold the warp threads under tension to facilitate the interweaving of the weft threads. The precise shape of the loom and its mechanics may vary, but the basic function is the same. Etymology. The word loom is derived from the Old English geloma, formed from G and loma, a root of unknown origin. This meant utensil or tool or machine of any kind. In 1404 it was used to mean a machine to enable weaving thread into cloth. By 1838 it had gained the meaning of a machine for interlacing thread. Weaving. Weaving is done by intersecting the longitudinal threads, the warp, i.e., that which is thrown across, with the transverse threads, the weft, i.e., that which is woven. The major components of the loom are the warp beam, heddles, harnesses or shafts, shuttle, reed and take-up roll. In the loom, yarn processing includes shedding, picking, battening and taking up operations. These are the principal motions. Shedding. Shedding is the raising of part of the warp yarn to form a shed through which the filling yarn, carried by the shuttle, can be inserted. On the modern loom, simple and intricate shedding operations are performed automatically by the heddle or heeled frame, also known as a harness. This is a rectangular frame to which a series of wires, called heddles or heels, are attached. The yarns are passed through the eye holes of the heddles, which hang vertically from the harnesses. The weave pattern determines which harness controls which warp yarns, and the number of harnesses used depends on the complexity of the weave. Two common methods of controlling the heddles are dobbies and a jacquard head. Picking. As the harnesses raise the heddles or heels, which raise the warp yarns, the shed is created. The filling yarn is inserted through the shed by a small carrier device called a shuttle. The shuttle is normally pointed at each end to allow passage through the shed. In a traditional shuttle loom, the filling yarn is wound onto a quill, which in turn is mounted in the shuttle. The filling yarn emerges through a hole in the shuttle as it moves across the loom. A single crossing of the shuttle from one side of the loom to the other is known as a pick. As the shuttle moves back and forth across the shed, it weaves an edge, or selvage, on each side of the fabric to prevent the fabric from raveling. Battening. Between the heddles and the take-up roll, the warp threads pass through another frame called the reed. The portion of the fabric that has already been formed but not yet rolled up on the take-up roll is called the fell. After the shuttle moves across the loom laying down the fill yarn, the weaver uses the reed to press each filling yarn against the fell. Conventional shuttle looms can operate at speeds of about 150 to 160 picks per minute. There are two secondary motions, because with each weaving operation a newly constructed fabric must be wound on a cloth beam. This process is called taking up. At the same time, the warp yarns must be let off or released from the warp beams. To become fully automatic, a loom needs a tertiary motion, the filling stop motion. This will break the loom, if the weft thread breaks. An automatic loom requires 0.125 horsepower to 0.5 horsepower to operate. Types of looms. Backstrap loom. A simple loom which has its roots in ancient civilizations consists of two sticks or bars between which the warps are stretched. One bar is attached to a fixed object, and the other to the weaver, usually by means of a strap around the back. On traditional looms, the two main sheds are operated by means of a shed roll over which one set of warps pass, and continuous string heddles which encase each of the warps in the other set. The weaver leans back and uses his or her body weight to tension the loom. To open the shed controlled by the string heddles, the weaver relaxes tension on the warps and raises the heddles. The other shed is usually opened by simply drawing the shed roll toward the weaver. Both simple and complex textiles can be woven on this loom. Width is limited to how far the weaver can reach from side to pass the shuttle. Warp-face textiles, often decorated with intricate pick-up patterns woven in complementary and supplementary warp techniques, are woven by indigenous peoples today around the world. They produce such things as belts, ponchos, bags, hatbands and carrying cloths. Supplementary weft patterning and brocading is practiced in many regions. Balanced weaves are also possible on the backstrap loom. Today, commercially produced backstrap loom kits often include a rigid Edal, warp-weighted loom. The warp-weighted loom is a vertical loom that may have originated in the Neolithic period. The earliest evidence of warp-weighted looms comes from sites belonging to the Star-Savo culture in modern Serbia and Hungary, and from late Neolithic sites in Switzerland. This loom was used in ancient Greece, and spread north and west throughout Europe thereafter. Its defining characteristic is hanging weights which keep bundles of the warp threads taut. Frequently, extra warp thread is wound around the weights. When a weaver has reached the bottom of the available warp, the completed section can be rolled around the top beam, and additional lengths of warp threads can be unwound from the weights to continue. This frees the weaver from vertical size constraints. Draw loom. A draw loom is a hand loom for weaving figured cloth. In a draw loom, a figure harness is used to control each warp thread separately. A draw loom requires two operators, the weaver and an assistant called a draw boy, to manage the figure harness. Hand loom. A hand loom is a simple machine used for weaving. In a wooden vertical shaft looms, the heddles are fixed in place in the shaft. The warp threads pass alternately through a heddle, and through a space between the heddles, so that raising the shaft raises half the threads, and lowering the shaft lowers the same threads. The threads passing through the spaces between the heddles remain in place. This was a great discovery in that era. Flying shuttle hand weavers could only weave a cloth as wide as their arm span. If cloth needed to be wider, two people would do the task. John Kay patented the flying shuttle in 1733. The weaver held a picking stick that was attached by cords to a device at both ends of the shed. With a flick of the wrist, one cord was pulled and the shuttle was propelled through the shed to the other end with considerable force, speed and efficiency. A flick in the opposite direction and the shuttle was propelled back. A single weaver had control of this motion, but the flying shuttle could weave much wider fabric than an arm's length at much greater speeds than had been achieved with the hand-thrown shuttle. The flying shuttle was one of the key developments in weaving that helped fuel the Industrial Revolution. The whole picking motion no longer relied on manual skill, and it was a matter of time before it could be powered. Haute-lisse and basse-lisse looms. Looms used for weaving traditional tapestry are classified as haute-lisse looms, where the warp is suspended vertically between two rolls, and the basse-lisse looms, where the warp extends horizontally between the rolls. Ribbon weaving. Traditional looms. Several other types of hand looms exist, including the simple frame loom, pitch loom, a freestanding loom, and the peg loom. Each of these can be constructed, and provide work and income in developing societies. Power looms. Edmund Cartwright built and patented a power loom in 1785, and it was this that was adopted by the nascent cotton industry in England. The silk loom made by Jacques Vaucanson in 1745 operated on the same principles but was not developed further. The invention of the flying shuttle by John Kay was critical to the development of a commercially successful power loom. Cartwright's loom was impractical, but the ideas behind it were developed by numerous inventors in the Manchester area of England, where by 1818 there were 32 factories containing 5,732 looms. Horrocks' loom was viable, but it was the Roberts loom in 1830 that marked the turning point. Incremental changes to the three motions continued to be made. The problems of sizing, stop motions, consistent take-up, and a temple to maintain the width remained. In 1841, Kenworthy and Bullough produced the Lancashire loom, which was self-acting or semi-automatic. This enables a youngster to run 6 looms at the same time. Thus, for simple calicos, the power loom became more economical to run than the hand loom, with complex patterning that used a dobby or jacquard head. Jobs were still put out to hand loom weavers until the 1870s. Incremental changes were made, such as the Dickinson loom, culminating in the Keighley-born inventor Northrop who was working for the Draper Corporation in Hopedale producing the fully automatic Northrop loom. This loom recharged the shuttle when the pern was empty. The Draper E and X models became the leading products from 1909. They were challenged by synthetic fibers such as rayon. From 1942, the faster and more efficient shuttle-less Sulzer looms and the rapier looms were introduced. Modern industrial looms can weave at 2,000 weft insertions per minute. Weft insertion. Different types of looms are most often defined by the way that the weft, or pick, is inserted into the warp. Many advances in weft insertion have been made in order to make manufactured cloth more cost-effective. There are 5 main types of weft insertion and they are as follows. Shuttle. The first ever powered looms were shuttle-type looms. Spools of weft are unraveled as the shuttle travels across the shed. This is very similar to projectile methods of weaving, except that the weft spool is stored on the shuttle. These looms are considered obsolete in modern industrial fabric manufacturing because they can only reach a maximum of 300 picks per minute. Airjet. An airjet loom uses short, quick bursts of compressed air to propel the weft through the shed in order to complete the weave. Airjets are the fastest traditional method of weaving in modern manufacturing and they are able to achieve up to 1200 picks per minute. However, the amounts of compressed air required to run these looms, as well as the complexity in the way the airjets are positioned, make them more costly than other looms. Waterjet. Waterjet looms use the same principle as airjet looms, but they take advantage of pressurized water to propel the weft. The advantage of this type of weaving is that water power is cheaper where water is directly available on site. Picks per minute can reach as high as 1,000. Rapier loom. This type of weaving is very versatile, in that rapier looms can weave using a large variety of threads. There are several types of rapiers, but they all use a hook system attached to a rod or metal band to pass the pick across the shed. These machines regularly reach 700 picks per minute in normal production. Projectile. Projectile looms utilize an object that is propelled across the shed, usually by spring power, and is guided across the width of the cloth by a series of reeds. The projectile is then removed from the weft fiber and it is returned to the opposite side of the machine so it can get reused. Multiple projectiles are in use in order to increase the pick speed. Speeds maximize on these machines at 1050 ppm. Shedding dobby looms. A dobby loom is a type of floor loom that controls the whole warp threads using a dobby head. Dobby is a corruption of drawboy, which refers to the weaver's helpers who used to control the warp thread by pulling on draw threads. A dobby loom is an alternative to a treadle loom, where multiple heddles were controlled by foot treadles, one for each heddle. Jacquard looms. The Jacquard loom is a mechanical loom, invented by Joseph Marie Jacquard in 1801, which simplifies the process of manufacturing textiles with complex patterns such as brocade, damask and matelassar. The loom is controlled by punch cards with punch holes, each row of which corresponds to one row of the design. Multiple rows of holes are punched on each card and the many cards that compose the design of the textile are strung together in order. It is based on earlier inventions by the Frenchmen Basile Bouchon, Jean-Baptiste Falcon and Jacques Vaucanson. To call it a loom is a misnomer. A Jacquard head could be attached to a power loom or a hand loom, the head controlling which warp thread was raised during shedding. Multiple shuttles could be used to control the color of the weft during picking. Hand-operated Jacquard looms. In the textile department of the Strzemiński Academy of Fine Arts in Lodz, Poland. Battening on a Jacquard loom. In Lodz, following the pattern, holes are punched in the appropriate places on a Jacquard card. Circular looms. A circular loom is used to create a seamless tube of fabric for products such as hosiery, sacks, clothing, fabric hose and the like. Circular looms can be small jigs used for hand knitting or large high-speed machines for modern garments. A good example of the circular loom's work is the seamless women's stocking. Gallery model of Navajo loom, late 19th century, Brooklyn Museum.jpg. An early 19th century Japanese loom with several heddles, which the weaver controls with her foot. A Jakaltek Maya brocades a hair sash on a backstrap loom. Hand loom at Jølhed, Denmark, showing grayish warp threads and cloth woven with red filling yarn. Oaxacan artisan Alberto Sanchez Martinez at loom. Bibliography. Barber, J.W. Prehistoric Textiles. Princeton University Press. ISBN 0-691-00224-X. Burnham, Dorothy K. Warp and Weft. A Textile Terminology. Royal Ontario Museum. ISBN 0-88854-256-9. Collier, Ann M. A Handbook of Textiles. Pergamon Press. p. 258. ISBN 0-08-018057-4. Crowfoot, Grace. Of the Warp-Weighted Loom. The Annual of the British School at Athens 37. 36-47. DOI 10.1017 per seconds 0068245400017950. Marsden, Richard. Cotton Weaving. Its Development, Principles, and Practice. George Bell and Sons. p. 584. Retrieved February 2009. Mass, William. The Decline of a Technology Leader, Capability, Strategy and Shuttleless Weaving. Business and Economic History. ISSN 0894-6825. Ventura, Carol. Maya hair sashes backstrap woven in Jacaltenango, Guatemala. Cintos Mayas tejidas con el tela de cintura en Jacaltenango, Guatemala. Carol Ventura. ISBN 0-9721253-1-0.